When voters are asked to vote on a single-dimensional issue, such as how much to spend on local parks, or how much to spend on the local police or local schools, we often assume that their preferences are single-peaked. We'll illustrate here what we mean by that, and why that assumption may often be reasonable. Suppose we put the level of a public good Y on the horizontal axis and the level of the private good X on the vertical. Voters know that as more public good is provided, the tax rate imposed on their private good consumption increases, and thus their private good consumption declines. The most private good consumption they can engage in is if there is no public good to be funded, and thus the tax is zero. This gives us the vertical intercept of what looks like a budget constraint, and in many ways acts as a budget constraint for how the voter thinks about how much of the public good she would desire. Taking the tax system that's in place to fund the public good as given, the voter would then treat this budget constraint the way she would any budget constraint, and determine her most preferred level of the public good by moving to the highest possible indifference curve. If she could simply choose the public good level provided under this tax system, she would then choose the public good level yi star. But voters don't get to impose their choice on everybody else. Each voter is simply one of many who will express her preferences in an election. The election outcome will usually be something different than the most preferred public good level of any single voter. If the election results in the magenta level of public good, then we can see that the indifference curve on which this voter will end up will lie below the blue indifference curve that's the highest possible one she could have reached. And there is another magenta public good level, this one above yi star, that gets this voter to the same indifference curve. The voter would therefore be indifferent between an election that results in the lower magenta public good level or in an election that results in the higher magenta public good level. Any election outcome that results in a public good level that deviates even further from this voter's ideal public good level of yi star will result in even less utility, with the two green public good levels again resulting in the same level of utility. In the lower panel, we now graph this information in a somewhat different form, with the public good Y remaining on the horizontal axis, but the utility level UI for voter I on the vertical axis. The utility level of the lower green public good quantity is then U double prime, the label attached to the green indifference curve in the upper graph. The lower of the magenta public good levels results in utility level U prime, the label attached to the magenta indifference curve in panel B. And the utility will reach its highest level, U, when the public good quantity reaches the most preferred public good quantity for this consumer, the quantity yi star. The higher magenta public good quantity then results in the same utility level as the lower one, and the higher green quantity corresponds to the same utility level as the lower green quantity. This is of course because the green quantities appear on the same indifference curve, and the magenta quantities appear on the same indifference curve. In panel C, we can now see a depiction of what we call single peak preferences over a single dimensional issue. The issue is the level of the public good Y, and this voter has single peak preferences over that issue, with one most preferred outcome and utility declining as we deviate from that outcome in either direction.